Hey guys, let's talk about real numbers this session. The first thing and very important to know here is a Euclid's division lemma. The whole chapter revolves around this particular topic, Euclid's division lemma. Now that's simple actually. It says given two positive integers a and b, there exists unique integers q and r satisfying this equation. So remember, all of them are integers. Okay, a is an integer, b, q and r, all they are integers, no decimals, no fractions. Keep that in mind. Second thing we'll also understand was dividend, divisor, quotient and remainder perfectly, and this particular equation where r has to be greater than or equal to 0 or less than b. Okay, to understand all the things, let's go with this simple example. I'm taking a as, let's say we'll start from 15, okay, and we'll change the numbers. Okay, a can be changed, and we'll try to understand what exactly is this with different a's. Basically, let's keep b a constant right now, which is 3. So when I take a as 15, I'm dividing it by 3, so I can write 3 5 times is 15. So what happened? You got the remainder as 0, so I can say that is nothing but a for me. Okay, this is b for b. That guy is nothing but the quotient q, and this guy 0 is the remainder. All right, so we have all the four of them, right? So dividend is nothing but a for me, right? What I'm dividing. Divisor is in this case b, so I can write it is 15 here and it is 3 here. Okay, what is quotient? How many times? 3 times 5, right? 3 times 5 is 15, so this guy is quotient for me, so I can write that is nothing but q, which is 5, and what is the remainder right now? R is 0 in this case. So we understand what happened right now, right? Can I write this whole equation in this form? Let's try that. A is 15. Can I write 15 as 3 times 5? I can. 3 times 5 plus this guy, which is 0. That works. So that looks like A is 3 was nothing but B, and 5 is nothing but Q, and 0 is nothing but R for me. So let me write this as R itself. So that is R. Come back to this. When I say this thing to understand, R has to be equal to 0. All right, I'm just explaining what this means. R can be 0, or R has to be greater than 0, or R has to be less than B. So right now in this case, I can see R is 0 here. Right, beautiful. So let's do one thing. Change A to 16 and see what's happening. So when I say A is 16 and B is 3 only, so I'll go with the division again. I have a 16 here, 3, and how many times it goes? 3 5 times again. You do get 15, but this time I get a 1. Okay, can I write this again, this equation here? I can write 16, yes, is equal to 3 times 5, right? That looks like a face here, this guy. So 3 times 5 plus, I'm adding 1 to it. Okay, that works. So that guy is nothing but A for me, which is B times Q plus R. Now see what happens to R. R is 1. So can I say R is greater than 0? Yes, it is. But R should also be less than B. Who is B here? B is 3. So can I say R is actually 1, which is greater than 0, and less than 3? Makes sense to me. So R can be only these things. It can be 0, it can be more than 0, but it has to be less than B here in this case. We'll talk about this as we go ahead. So let me change A as 17 and check. So B is anyway 3 for me. See what's happening again. I'm getting 17 here. 3, I'll be a little fast now. 5 times it gets 15. You get a 2 here. Okay, it says 17 is nothing but 3 times 5. That is 3 times 5 plus 2. Look at this. What's happening to R? Okay, I can write this to be A is equal to B times Q plus R. So now see, I can see R is 2. Beautiful. Is R greater than 0? Yes. Is R less than 3? Yes. Beautiful. So in this case we had R to be 0. In this case we had R1. Again, I can say R is actually greater than 0 and R is less than 3 in this case. What can be the next equation? I'll take A as 18 this time, and I can take B as 3 again. I'm just trying to increase one number here. What happens? If I do the same thing, I'll get 3, 18, and you can write 6 times and 18, I get a 0. Look at that. So I can write 18 is nothing but 3 times 6 plus 0, and I can write this to be A is nothing but 3, or 3 is nothing but B times Q, right? That guy's 6 here, right? 6 plus R. So what is R again? 0. So R is 0. Yes. So can R take any other value other than 0? This possible. This possible, yes. But if I have one number more than 15, that is 16, I get R to be 1, which is definitely greater than 0 but less than 3. Okay, in this case it was 2, greater than 0, less than 3, but in this case 8 becomes 0 again. So it means R can only be what? R can be 0, or R can be greater than 0, or R can be less than B, or in this case it is less than 3. Alright, so come back to this guy. We understand this very, very clearly, isn't it? Now what if I do it this way? If I do it a little wrong, what if I take 5 here in this case? So if I take 5, what I get here is 15. Alright, and I make it the remainder to be 3. Would that be correct? That should not be correct, right? You know why? Because R here is actually greater than or actually equal to 3, where in this case it should not be. It has to be less than 3. It cannot be 3, right? It has to be less than 3 or less than B basically, and B is this guy. This division is wrong because I can divide 18 one more time, not 5 times. I can actually divide 18 6 times, right? So that's a wrong division. That's what it is. It's a simple thing. This is valid, this is valid, this is valid, but here this guy is not valid. If it goes like 6 times and get 18, that is valid again. So definitely I cannot choose a Q such that it gives me a remainder which is equal to the divisor, that is B in this case. This is what exactly is division lemma, guys. Now I can write all these equations in the same way, right? Beautiful. So let's come back again and understand. Given 2 positive integers, A and B, that is A and B, I can write them in another equation called A is equal to B times Q plus R, where Q and R are 2 new numbers we get. In this case, Q is 5 and R is 0. In this case, Q is 5 and R is 1. In this case, Q is 5 and R is 2. I did it wrong, right? Previously we took it actually 6 here. So that was 6 and that was 18 and the remainder was 0. So that case is right. If we understand what exactly is division lemma now. Now let's take another example to understand the concept a little better. I'm taking A to be 12 and B this time is 4. Okay, last time we took B as 3. Let's see what's happening here in this case. If I take B as 4, 12 I can divide 3 times 4 is 12. We get the 0 as remainder. We can write this as the division lemma. Now what important here is the remainder is 0. Look at that. So remainder is 0. Right, so that's happening here. What if I increase? What if the integer is not 12, it is 13? So I can get 3 times 12, and I can write 1 as the remainder. I can write in the lemma, and I can see R is equal to 1. So R is definitely 1, and I can see that R is greater than 0, which says this guy, which R is greater than 0, and R is less than B. Definitely, because R in this case is 1. So I can write 1 is definitely greater than 0 and less than 4. So it makes sense to me. But I compare this guy again, I can R at 2, which is greater than 0 and less than 4. Works. What about this guy? R is 3. R is basically, I can write 3 here. That is 3 is less than 4 and greater than 0. Makes sense. Now, here's a little critical thing, guys. When I take A to be 16, okay, I'm just taking one more integer and coming, and I can see that in this example, A is 16, I'm taking B as 4. I can do it in 2 ways. If I take 4 times 16, I get a 0 here, and I can see R is again back to this guy. That is the first one. So this cycle repeats. So R can be 0, it can be 1, it can be 2, and it can be 3. Here I can see very easily that R is equal to 4, but that doesn't actually satisfy the condition. I know that R has to be less than B, and in this case, B for me is 4, right? So R cannot be equal to 4. R has to be less than 4. So for the equation, this equation to be satisfied, or a lemma to be satisfied, this is the last thing you can take, and this division is wrong, okay? Because I can actually divide 16 like 4 times, not 3 times. So that is wrong division, right? I can divide it one more time, like 4 times is 16, and the remainder is 4. So that division is wrong. That's what it explains to us what is division lemma, and it has to be this equation, and definitely R cannot be equal to B also, all right? It has to be less than B. B here in this case is nothing but the divisor, all right? So R has to be, the remainder has to be always less than divisor. If it is equal to divisor or more than divisor, it means your division is wrong. So we understand this, guys, very simple. Once we follow these rules and we can write this equation, what we get is nothing but the Euclid's division lemma. That's all about it.